Welcome back, everyone. In this lecture, we're going to have an overview for the Convolutional Neural Network Exercise Notebook. This is a pretty simple exercise. It's basically having you run through a set of data that's very similar to the MNIST digits data set. So let's take a look at the notebook and what you need to do. Okay, here we are at the exercise notebook. So for this, you're going to be using what's known as the Fashion MNIST dataset. And this dataset includes 10 labels of different clothing types, along with 28 by 28 grayscale images. So really similar to the MNIST dataset with the digits, we have 60,000 images and 10,000 test images. And they have a variety of descriptions and labels. So it's like things like pullovers, dresses, coats, sandals, sneakers, ankle boots, etc. So you can go ahead and load up the data. It's built into Keras by running these two lines. And then we'll just have you essentially go through the same workflow that we've been going through for the previous lectures. Things like visualizing the data. So here we can see an example image. And then it will have you pre-process the data by normalizing it by dividing by the max values, then reshape the data to include that singular color channel, things like convert the Y-train and Y-test values to be one hot encoded, and then we'll have you build out the model. You actually have a lot of flexibility. You don't necessarily need to follow out the layout we did here. This is just what the solution itself and the solution notebook went through, and you can always edit these things. You can't edit things like the loss, but feel free to play around with the optimizer. You don't need to use RMS propagation. You can use something like Atom, etc. Okay, so after that, go ahead and then train the model. So if you want, you can add an early stopping to choose the amount of epochs for you. But here we just went ahead and trained it for 10 epochs. Again, feel free to add in that early stopping. And then we want you to evaluate the model. So essentially at the end of all this, basically we just want you to be able to print out a classification report on your model's performance. And you should get pretty good performance, somewhere around overall 91 or 90% accuracy or recall. Okay, so feel free to edit any of the parameters you want here inside of this network. But coming up next, we'll go ahead and walk through an example run through of the solutions. I'll see you there.